The volume of all of the prisms that are shown in here all have something in common. They have a front and a rear face that are the same, and there's a distance between the front and the back. So the volume, this B here, we'll call it beta, and I'll write it like that. In the case of the triangle over here, the area of the front face, beta, would be 1/2 base times height. In the case of the next shape, it's a rectangular prism, and beta in this case on the top is either a square or a rectangle, and its formula for the area of that front face is just base times height. So for every one of these prisms, regardless of what the front face is, the volume is going to be whatever the area of the front face is times the distance between the front and rear face. So volume equals beta depth. So what about a cylinder? And with a cylinder, the area of the front face is going to be a circle. So beta, which is the area of the front face, we would replace that with the formula for the area of a circle, which is pi times the radius squared. And we bring down our d. Now we simply plug in the values. So we'll get pi times 5 squared times 4. 5 squared is 25. And 4 times 25 gives us 100. So our answer is 100 pi, which works out to about 314 inches cubed, 314.15. On this problem, there are two differences. First, you're given the volume and you have to find the depth of it, the distance between the front and rear faces. And even though this line's length is the same, as you tilt the cylinder to one side, the two faces will become closer to each other. So the depth, the distance between the front and rear face will change, even though the length of this line does not change. So D is not the length of this line, it's the distance between the front and rear face. So beta in this case is the area of a circle, and we're going to substitute the numbers that we have. So first, I know the volume is 176. I know that the radius is going to be 4, and 4 squared is going to be 16. So on the right side, we'll have 16 pi d. And then to find the distance between the front and rear face, we divide both sides by 16 pi. So then we're going to divide 176 by 16 pi. So 176 divided by 16 divided by pi gives us approximately 3.5 centimeters. Volume is the amount of space inside a shape, but surface area is simply if I was to open up the shape and put it flat in 2 dimensions, you would have 3 shapes here. And if you think about the circles on the top and bottom are identical, and the part that connects the 2 circles to each other, if opened up flat, is a rectangle. Now, to the original figure of the cylinder, we'll put in a few measurements, so then we'll transfer them over to the net. So now, to find the area of the circle is pi r squared, and the radius squared is going to be 8 squared, or 64. So the area of each circle is approximately 201 square inches. And for the final part, the rectangle, we know that the height here is 5 inches. Now looking at the rectangle, when I fold up the rectangle, I see that the base, which is going from here to here, that this wraps around the circle, so the base of the rectangle is actually going to be the circumference of the circle. And the circumference of a circle is 2 pi r, or pi times the diameter. So in this case, it's 16 pi, which works out to approximately 50.26 or 50.3. So that is going to be the base of our rectangle. So the area of the rectangle is approximately 251 inches squared. So now for the surface area, I just add up the area of each of the 3 shapes. So the total for the surface area is approximately 653 inches squared. It's square inches because it's area. In this next example, we're going to find the surface area without drawing the net first. So some textbooks give a formula, not in the initial introduction for surface area of a cylinder, but this formula would give you the surface area of the cylinder because it's broken down into essentially 2 times the area of the front and rear face. And then this over here is the rectangle. The base of the rectangle is 2 pi r of the circle times the height, and the height is the distance between the front and rear faces. So substituting in our values, the radius is 7.5, 7.5 squared is 56.25. So further simplifying, 56.25 pi is 176.4. And to that we're adding 2 times 5 is 10 times 7.5 is 75. 75 pi equals approximately 235.6. And then I'm going to multiply 2 times 176 equals 353.4. And then the surface area is simply the total, which is approximately 589 meters squared. For this last figure, why don't you pause the video and see if you can find the volume and surface area on your own. I'll give you about 3 seconds to pause. So first we'll find the volume. So volume equals beta depth. Beta is the area of a circle, so I'll replace the beta with pi r squared. Next, in order to substitute, I'm going to replace the radius with 12. 12 squared would be 144, and the depth is going to be 10 feet. Simplifying, I get 1,440 pi. And 1,440 pi using our calculator. So we get 1,440 times pi. And rounding to the nearest whole number, we get 4,524. And the units are feet cubed. Now for the surface area, I'll find the area of the 2 circles and the area of the rectangle. So I'll list it like this: circle 1 area, circle 2 area, rectangles area, and then we'll get a total. So for the first circle, I have area equals pi times the radius squared. Well, the radius squared is 144, so this is 144 pi, which works out to approximately 452.4. And that'll be each of the 2 circles. Then in order to find the area of the rectangle between the 2 faces, I have to find the base of it. I already know the height is 10. So the circumference of a circle is 2 pi r. Substituting in for r is 2 times pi times 12, which is 24 pi. So the base of the rectangle is 24 pi, and the height of the rectangle is 10. 24 pi times 10 is 240 pi, which is approximately 754 feet squared. And now I just get a total of these 3. So our surface area is 1,658.8 feet squared.